What would happen if there was a defect in traffic flows? To answer this question, I'd like to show you an interesting phenomenon we coined disorder induces order in a non-equilibrium system. The symmetric simple exclusion process called ASEP is a simple non-equilibrium transport system, such as traffic flow and diffusion along DNA. In ASEP, many particles diffuse on 1D lattice with hardcore interaction. The hardcore interaction implies that the particle can hop to the right only if the right side is empty. Moreover, hopping dynamics follow Markovian one. Therefore, the waiting time distribution follows the exponential distribution. We consider any particles on a ring of L sides, that is, the periodic boundary conditions. Moreover, we consider the extreme case, P is equal to 1. This model is called totally ASEP, that is TASEP. This is a movie of TASEP where n equals 25 and the number of side L equals 50. As you can see, local densities are fluctuating. In particular, there are low density and high density phases. Therefore, phase separations occurs in this system. The phase separation is not static but dynamic. In particular, our local density dynamically changes from low density phase to high density phase. In other words, low density phase or high density phase merges everywhere. Here we introduce disorders in the TASEP. In particular, we consider the TASEP in a quenched random energy landscape. Therefore, hopping rates depends on the size. This is a movie of a TASEP in a quenched energy landscape where n equals 25 and L equals 50. As you can see, there are low density and high density phases, which is same as the homogeneous TASEP. So the phase separations occurs in this system. However, unlike the homogeneous TASEP, the phase separation is somewhat static, not dynamic. In particular, the boundary between the high density phase and the low density phase is the site with the maximum mean waiting time. This is a phenomenon coined disorder induces order. With the aid of this phenomenon, we can derive transport properties analytically. See our papers in detail, which is described in the abstract of this video. In summary, phase separation occurs due to many body effects in TASEP. Local phases do change in homogeneous TASEP. On the other hand, local phases do not change in the disorder's TASEP. Therefore, we find an interesting phenomenon called disorder induces order in the disorder's TASEP.